Next up, we're going to hear from another car company. Another German car company, BMW this time, designed for sustainability with wooden structural components. Delighted to welcome to the stage the project leader, Design for Sustainability R&D, Stefan Koensgen from BMW.
Yeah, a very warm welcome from my side. I would like to give you some insights today of my daily work and of our teamwork in the last 3 years. We had, I would say, one of my most exchanging times in my work life. So, and I would like to give you some insights here. The title is a little bit leading, and first, I don't know if everybody is 100% familiar, but our understanding of design for circularity is based on how we build cars in the future, because that makes a big difference when we talk about end of life, dismantling. The joining technologies, so how we're going to bring these components and materials and parts together, and one of the most important areas, the material itself. So the combination of materials which we choose, materials which have CO2 reduction potentials, and I'm sure we have a lot of wonderful experience here in the room. And one topic also important to understand is to avoid materials which are really hard to separate at the end of the day. So when we look a little bit at the two sides of, so to say, the potentials of recycling, on one side you can really mechanically tear it down, the whole car, and you're going to have a picture like this. And as you imagine, or maybe can imagine, that's not so easy to separate it and bring it really back into a circularity. And on the other side, if you do 100% full disassembly, and you look at the cost, that's maybe also not the most efficient way. So within the regulations from the EU, which just coming out, we have to find this sweet spot in between these two. And that is a very interesting challenge, because as you have heard already, cost is always an issue here. When we talk about design for circularity, what we have learned and tried is to implement in our design thinking already the second and the third life of a car or of a component. So when you understand what you want to do with this component in the next life, you need to understand how you can separate it, how you can recycle it, and how you can make something worse, something good out of it, which is then useful in a closed or in an open loop. Yeah? And here I brought some examples what we have done with that example where I will talk about with the wooden-based structure material, replacing and substituting plastics. You can bring the fiber down to a certain point, then you can build a new composite material. Then you have the next level, which is then a door panel, and then you can tear it down again, and you're going to get particles, and that can be used in other industries like furniture. So we are already starting in this early phase to think about the next life, and also we start talking to companies which are maybe cross-industry, which don't even have something to do with automotive, because there's a great learning experience in that level. So what components tried, I'm from the interior, so to say, so we have major components which are heavy, so they have a big CO2 impact, and CO2 reduction is also another big target towards 2050 for sure. And so we took the seat, we took the cockpit, we took a center console, and we tried to build it completely new. So when you start with such a journey with a material you don't even know or understand, really, because so far we have steel and plastic. Then you try maybe, okay, what can you learn from other industries like furniture? How do they build things? You try in the first level maybe to do a one-by-one design to replace the steel beam and the cross-car beam, but that doesn't work because the connectors maybe they don't work. It's getting too complicated, and then, so to say, you restart again. And then after some tryouts, we understood, okay, we have to build completely and design completely in a different way. So we tried to replace the structure of steel partially. In the beginning, we tried to do it 100%, and then we replaced the plastic part by this wood piece. That's a veneer wood. So you're gonna take it from a tree as a so to say cut down process, and we need to have several layers to have this stiffness, because every piece in a cockpit is so to say assembled to this structure material. So we talk about 60 kilogram or so, which are hanging, so to say, in between the A columns, and that, as you can imagine, you have vibration, you have crash, you have different things which are in a car. When we did the first step, we tried to replace fully the steel, but there's one issue where we failed. And also, design for sustainability and circularity means you have to fail, but you have to fail and you learn, and you're going to have to do the next thing to move forward. So if we would build this piece completely out of wood without the steel, a little bit steel structure here in the color, as you can see, we would have to add so much material that at the end of the day, the process and the assembly and also the cost would never work. And so we took partially the steel, but we replaced a lot of it. What is interesting, just going one slide back, because of the stiffness in combination with low weight reduction, and also for the CO2 footprint. Wood is interesting because it's industrialized available. Wood is interesting because it's local, it's resilient. We're going to use a beech here, so which is in Germany or in Austria available. 60% of the forest in Germany is beech, and we have 1 million hectares of beech wood forest. So the scalability is there already, and the processes to work with it are already there. And as we have learned also in the very beginning, when my colleague of Mercedes was talking with the startups, to use existing industries is going to help to bring innovations to life. So wood is one important and very interesting material in our research thinking, and cork is the other one. And the nice story about cork is that cork is a material which is energy and acoustic absorbing. So one of the major jobs we have is to save people's life and to have passenger safety. And with this material, we can assure that the energy will be absorbed inside the material. And that's a really big advantage. So now what we do is we usually the cork oak, where the cork is coming from, is used for the wine stoppers, right? So they cut it out, and we use the waste from the wine stoppers, which are either not good in quality or which are, as you can see in this picture, so to say, the rest. And we make granulates out of that with our partner companies. And these granulates can be then binded together with a bio-based binder, and they can be 3D shaped to really nice volume. So with the wood piece for the stiffness and the cork, in combination here with the three-dimensional forming, we can add surface on top of it, and we're more or less ready to go. And the nice thing is also, when you start thinking about this, you can integrate air channels, for example, inside. As you can see in here in examples, we did some tryouts with different surfaces. You can bring the normal leather or sustainable materials on top of the cork, or you can bring wood on top of the cork as a premium material, and inside, as you see, is the air channel integrated. So that means we save parts, and that means we save money, and that means we save assembly. One point interesting, maybe in addition to the forest and to the wood, here is compared industrialized forest versus just leave the wood alone or the forest alone. And as you can see, when you put all these things together for carbon storage, we have here a natural carbon storage effect that is even higher than if you leave the forest alone. Especially for beech, there are some studies that show that after 100 years of growing, the CO2 is not taking more out, so there's an equal balance. So we went into the forest. We did look ourselves into these materials. We did talk to people which daily life is to work with this wonderful material, and was a very nice learning curve, to be honest. Here you can see the complexity of a cockpit. So we're going to have a structure material, we're going to have volume material, we have air channels, we have airbags, we have, and they all have to be joined together. So joining technology is in our assembly plants today, in most of the cases, just screwing or gluing. And screwing is okay for disassembly. Gluing is, maybe not so easy, or you want to create something where you can leave the materials together. So this question of how to design the joint is a very important issue. Besides the materials and the way you design, you have to create something to learn and understand how the material performs. So you have to go in very early prototyping. And we have one of the hardest tests with the head impact, with the climate change, with the shaker, with the knee intrusion, with the side crash and all of that, which is really not easy to overcome. So we had to build a prototype early with prototype tools. And you know, prototype tools are also not so easy sometimes because they not generate the 100% quality. But the learning effect is very important because you have to understand the materials, how they perform, to make a material card, to make a simulation so that the engineering in the early phase is done a little bit easier. And okay, I see in your faces they are working, and that's good because now you understand the complexity a little bit inside these topics. When we make something new, we can just replace a material here. No, there's a lot more to look at and to do, and that's good when it starts that way. But the nice thing, and I would want to showcase, is the result after 3.5 years. So we really have done testing, and we have a performance which is good. So we proved that it is possible that these materials they have a lifetime guarantee to go into a shaker, to go in a climate change, they have the stiffness which is needed in combination. They perform very well in the head impact. You see this curve, it's a wonderful curve. So we have some laws in US still, unbelted, somebody hits with his head on the cockpit, and there have to be a negative acceleration so that the neck is not broken. Makes sense or not, but that's what we have to fulfill as an automotive manufacturing company. We have side crash and knee intrusion, and all these requirements are developed over a long time of period, and we did show here that these materials have the potential to replace steel and plastic, what I've even shown before. Coming to the joints, and joyful joints, because we played around with a lot of joints, is also a very interesting point for the assembly. And we created one system, just one lock, you can just turn. So you plug in the parts, pieces together, and then you just turn it, and we have one tool, and then this thing is assembled. Yeah. So sounds easy. The colleagues were not so amused about our idea and concept here. So we had to go back a little bit again, because the plants are doing screwing and such things, and to change that would make a major investment. So we left that out, okay, went back to screwing, but at least we did show that there's another potential maybe in the next generation. Besides the interesting facts and properties of the material, wood is wonderful to treat. You can do a lot of designs and things like that, so that's also important for a premium car manufacturer as we are. And at the end of the day, we did showcase and build a model like this. And you can see the wood. By the way, we developed a new passenger airbag because it didn't work for us, but that's just a side story. It's under development still, because the, so to say, the way of exploding today, the passenger airbag is for wood not so really a good idea, yeah, so to say that. So we did have to do a separate module, which is, by the way, then again interesting for, gives advantage for disassembly and assembly. So the story of designing, and I love it, is you learn every day, you challenge every day, and you're gonna get results you never started thinking about in the beginning. So, and that's how I want to finish my speech. Thank you for being here.